Okay, welcome to the Dublin Academy of Maths. Now, today it's Series 3, Episode 8, Paper 1, and it's Calculus, and this is the last video for non-paying series, so this is all free. Now the rest of the videos I'll talk about later. Now today what I'm going to do is it's rates of change, okay? Now this is your normal function we had before. We had where you go up, f of x is greater than 0, so that means y is greater than 0. When you go down, you understand that the slopes is going down, okay? So anything above this line, f of x is greater than 0, anything below that line, f of x is less than 0, because f of x is equal to y. Okay, so every time you read lower than this, y is minus. Now I'm going to talk a little bit about rates of change. Now this is question 7c, usually in paper 1. Now it's the last part, so it's really the icing on the cake really. Now if you can get to understand it, it'll be all the much better. Now so I'm going to try and explain what Newton actually did. So for hundreds and hundreds and hundreds of years, everybody was making all these mathematicians were making graphs, okay, related to x and y, okay? But along came Newton and described this graph in a function known as the first derivative. Now, where did he get the first derivative? Okay, well, anyway, let's deal with a few things first. So he changed this graph. So he changed this graph to a quadratic graph. Okay, so it went from a cubic to a quadratic graph. Okay, so in other words, he reduced this information to a simple graph. Now the graph is usually negative graph. Okay, usually sometimes you see a positive graph. Right. Now remember, your solutions to your graph are on this line. Now if you have a problem with, now you remember that when you're walking, you're covering a distance over time. Okay. So for example, if I'm in a car and I'm traveling 60 kilometers per hour, it means that I'm getting from A to B. If it takes me 1 hour, or if it takes me 1.5 hours, I have to do a little maths thing. And the little maths thing is speed is equal to distance over time. Okay, so you can calculate a lot by manipulating the formula. Ts is equal to d, t is equal to d over s. You understand what I'm saying here? But all you need to know here is that speed is equal to distance over time, and it's relative to the y and x axis. So it's the speed, the distance you cover over the time, okay, is known as speed. Now he gave that a formula so that all curves could be interpreted this way using his derivative function, the rule. Do you remember the rule he used? X to the power of n times n times x to the power of n minus 1. I seem to get that always wrong. n times x to the power of n minus 1. So he reduced this down to this formula by a simple by using this formula of any curve. So he could find the mean average, which is the mean average speed that curve would take. Okay, so really he gave it now a three-dimensional look at, you know. So if I'm going from A to B, right, and it takes me an hour to get, I know that it's 60 kilometers away. Okay, now if it took me an hour and a half to get from A to B, and I was traveling at 60 kilometers, it means I passed through a time and I decreased my speed. Do you understand? And then I increased it again until I hit the town. So what he has actually done is he has given an average speed of overall, but not including acceleration, right? So that's to remember that mainly is that not to include acceleration for speed. So he brought out these formulas, and the formula first of all is speed is equal to distance over time. So ds dt is the formula. dy dx, if you want to look at it that way, dy dx. Now if you have a problem with t's and all that, you can substitute them because they're all relative. They're all related to the graphs we have done before on functions. Okay, so speed is equal to, so when you see speed, when you see velocity, it's the first derivative after t seconds, and speed is measured in meters per second. Okay, now you have to remember that, meters per second, speed. So once you see the speed, you meters per second. Now most formulas that come in this way is a quadratic. Do you see the quadratic? And you can solve those quadratics. In other words, you can find the slope, you can find the points, the start, and you can find the finish, and you can find using the slope formula, using the Newton's slope formula. You can find the slope at any time, or you can find the mean average speed, the mean speed. Now, so this is a question 2010. I better just do one more thing, and that is bring it back over, and we'll do. Well, if you want to get the let's just rub this out here. If you want to do the second derivative, that is the acceleration, you have to go d squared s over dt squared. That means not only when you see the word acceleration, de-acceleration or acceleration. Okay, it's the same as d squared y over dx squared if you want to look at functions, and it's measured after t seconds. It's measured and it's meters per second per second. Okay, so in other words, it's meters per second squared. Okay, so that's where that comes from, meters per second per second. So you're showing the acceleration and you're showing the de-acceleration. Okay, now back to this question. We'll have a look at this question, and we'll talk. I'm doing more talking today than I've ever done, I think. So we're going to bring it down across. I'm going to rub out this part. So you've understood this. This is how he has changed everything. So people now could, or we could now get a better understanding of graphs and motion because of his interpretations. Right. So we do this question here. So 2010, V is equal to 96 plus 40t minus 4t squared. Okay, now it says this is 2010 and it's question 7C, paper 1. And it says the speed V, so V is speed, okay, so V is speed. I'm going to put this in black. V is equal to speed, and where am I? Of an object at the time given by, at an object at the time t. Now, this is the formula, in other words, to give me. So it started somewhere and it ended up somewhere at a velocity, and it de-accelerated, as you can imagine. Okay, because something doesn't go on accelerating to infinity. So t is equal to seconds, so it's in seconds, and speed is measured in meters per second. Okay, and acceleration would be meters per second squared. Acceleration is meters per second squared. Now the question says, at what time will the speed of the object be 96 kilometers per 96 meters per second? When or at what time will speed equal 96 meters per second? Now this is already done for you in speed, okay, because speed is sometimes represented as V or velocity or speed. Okay, velocity and speed is the same. There it is over there, velocity and speed. So this is equal to 96. So at what time will the speed equal that? So you have to make that formula, 96 plus 40t minus 4t squared equal to 96, as you would do in functions. 40t minus 4t squared is equal to 0, because that taken away from that is 0. I factorize it, I take out 4, it's a common one, 4t. Okay, 4t by what will give me 40t. 4t by 10. 4t by what will give me 4t squared. 4t by t is equal to 0. I break them out, so 4t is equal to 0, or minus t is equal to minus 10. T is equal to 10 seconds, or t is equal to 0. So at the start it had no acceleration. So the answer, so at the start it was after t is equal to after 10 seconds. Okay, so this, at what time will the speed, so after 96 meters per second, it will, at the time will have taken 10 seconds. Okay, so you see how his formulas now, they've now been able to put direction on, and they've been able to predict when he's going to, when it's going to arrive. Okay, so there's a lot in this once you keep looking at it. So that's after 10 seconds, so from the start, so that's from the start, from 0, it took 10 seconds before it reached the 96 meters per second. This is amazing what he has done. Okay, And this can also be brought into a lot of other things, which I will go into later, okay? Not too much, but anyway. So that's the answer to that one. It's a bit dirty today. Alright. Right. And so the next part is, so that was t is equal to 10 seconds. Now it says, what will the acceleration, so once you, part 2 it says acceleration. Once it mentions acceleration, okay, you know that it's going to, you have to get the second derivative of this. Okay, value, the derivative of a constant is 0. 40t is going to be 40 minus 8t. 2 times 4 is 8t. And so that's the second, that's acceleration. So now he can tell you where you're accelerating through to this curve, through the curve. Okay. Now, so we're back to the question. At what time will what will the acceleration of the object be at 2.5 seconds? So when t is equal to 2.5 seconds, what's the acceleration going to be? Well, there's the formula for acceleration. Put in your seconds and you get out an answer. Okay, what's your signs? And that is going to work out as 20 meters. So at what time will so it'll work out 20 meters per second, which is 20 meters per second squared. So you put the time in and you found out that after 2.5 seconds his acceleration speed was 20 meters per second squared. So he was going up in the graph. He was going in that direction that quickly. Okay, at a certain point time. Okay, so there's t. Okay, and that's the distance. All right. Right, so that's that answer. The next part is, at what value of t will the acceleration become negative? So when will, this part 3 is, when will acceleration be negative? Okay, so part of this program is, when is this going to become negative? Well, it's going to become negative is when 40, we go back to our acceleration formula, is less than 0. That's when it's negative. Okay, it means that the slope is less than 0. It means that it's not going up, it's going down. Okay, so the moment from when it goes down, and then you get to solve it. So minus 8t is less than minus 40. T is equal to minus 4. Now remember, multiply. This is an inequality sign. You'll find this in a series 1 algebra. Very important. It's on YouTube. So t is equal to, change the sign, direction of the sign greater than, minus 40 divided by minus 8 is equal to t is greater than 8 into 45 seconds. Alright, t is seconds. So after 5 seconds, the acceleration was negative. Okay, so if I bring this over a bit, I can further look at this. So he's going up, and then after 5 seconds, so here is 5, minus 5, after 5 seconds he starts to decline. Okay, that's the acceleration. Now, most of the, as you've noticed, most of the quadratics are in this form, plus bx plus c. Okay, you've seen that before. So that's a negative quadratic. Don't go changing it. And if you do go changing it, remember, you change the direction of the sign. If you multiply across by a minus on this a squared, you change the direction of the sign. Okay, that's a clue there now. Don't go changing the whole meaning of the function regarding acceleration, because you get an opposite answer in the end. Okay, so that's a question done, right? There's nothing really more to add to this except that I'll just denote a few things here that I've set out here. Now the SDT has meant so much that now financials markets are doing it. You know, you put in your principal and you get out after a certain time, so you've got principal over time. So you've got financial flow charts for this. Flow diagrams. Okay, that's just another interesting part. It's a huge part in university. You got binary code. Binary code was developed because of sloping up and down currents, integrating currents, so you're hitting points, so you're getting 0, 1s at certain levels. Another 0 out here, maybe. You understand? So this binary code led to C++, which led to your apps. Okay, and the apps are like, for example, strawberry shortcake or blueberry. No, that's one of the app platforms. Okay. So now he has really Newton. What he done was he had pinned the answer. Okay, he had pinned the question. In other words, he'd given us a description of what of how the 3D workings of accelerations was happening. You know, which led on to 4-dimensional, which was a precursor to quantum theory. Even though he did reduce it by 10 years. Okay, remember our poor friend that lost his ended up destitute. But that's his only negative part of his life. For Newton. Now it also affected volume and flow rates. Okay, so he really got this. Really got, you know, you can now get volume. So you can get the volume over the time now. You know, the distributary, the flow of water over time, or a liquid over time. So you got dV/dt. Okay, volume over time, and he was able to, you know, they were able now this time be able to tell you in a pipe by the certain dimensions. Now not only we have the area, but you can tell you how much water or liquid flows through that, and a maximum minimum point, and where can it go, okay, and how much. So it really has changed a lot in the understanding of mathematics. Now we also have slow down rates, and slow down rates is gravity. So this is deceleration, okay, and this is acceleration. Now, and when you're getting the d squared, d squared s over t squared, which is the acceleration, you have to remember that you will probably just get a line. Okay, so you will get a part, you'll just get a line as such. Okay, so remember that. Or a number. Okay, so you mightn't get the t, or you might just get a number. Okay. Other things to show here. Now for the next day you have to do question, you have to do 2009, question 7C, paper 1, 2009, okay, and it's do that question. Okay, what value of t will the acceleration become negative? We've done all those. Okay, now for the future, now this is one of the last videos, so after this it's you have to buy into it if you're interested. You will get support for that. Okay, so support. You will get extra videos, extra vids on the on doing the questions on papers, because that's the next step. All the questions they're all covered. They're all covered regarding the practicality of how to do them. Please don't copy and send them off to your friends, because then it gets diluted and I don't get any quality back and I get no money, and then I lose interest and I don't keep it up. So no copying, pretty please. Okay, remember that they don't get any support, and they're probably going to end up, well, they will end up blowing. Some series relates to questions on papers. Okay, so every series, so in series, for example, the last one we've done 7 and 8, sorry, series 3 and 2, series 2 and 3. And they basically cover 3 questions, okay, in the papers. So anyway, in this series, in paper 1 there's going to be 6 series. And then in paper 2 we'll have a look at paper 2. I haven't started yet, only one question. Well, paper 1 is 6 series. Okay, so whatever you want, whatever your problem is, look at the paper and decide where you're weak at, and go for the series and say, Michael, I'm dublinacademy@gmail.com. At gmail.com is my address, or you can go Dublin Academy Online, which I will start promoting. dublinacademyonline.com online.com. Right, so that's everything. Yeah, so remember that the series is €20. I mean, that's 10 videos, 14 videos actually when you count the extras. So you're going to get all the videos in the package, and then you'll be able to start your questions from 0 and do all your questions. Okay, so there's about 48, 49 questions. This is around the 49th question. So if you get busy on doing them, you'll be doing great. Now, calculus was very interesting for me. I hope it was interesting for you. You can see that there's a huge thing out here. And I just wanted to say that Newton opened doors for us, not only improving Galileo's theorems, because Galileo was put away for a long time because of his ideas about orbiting bodies, and he improved classical engineering methods right up to financial markets and your mobile apps. computers. Thank you. God bless.